Hello friends, my name is Dr. Rajeev Kumar Chauhan. I am a senior member of IEEE. I have done PhD from Indian Institute of Technology, Mandi. Currently, I am working as assistant professor with the Department of Electrical Engineering at Galgotia College of Engineering and Technology, Greater Noida. I am a former research scientist with University of Manchester, United Kingdom. Today, I am going to discuss about digital logic design. In the module 1, the number systems and its arithmetic. So, today I am going to discuss the example in which we are going to convert the fractional decimal number to the octal number. So, how we will follow the steps? So, like we have the in this example we have the 0.513 decimal number. So, in this decimal number we want to convert it to the octal number. So, if we want to convert this decimal number to the octal number, so we will take it as a in this column and we will multiply it by the base value 8, because the base value for the octal system is 8. Okay. So, after multiplying 0.513 by 8, we will get the value is 0.513 is multiplied by 8. So, we will get 40. Okay, 4.104. So, in this the 4 is the integer number, while this one is the fractional number. So, we will write down the fractional, we will divide this now the resultant of the calculation of multiplication of 0.513 multiplied by 8. The result of this one we will divide into two parts. One is the fractional number and second one is the integer number. So, integer number will be write down here, while the fractional value will be here, and this integer will behave as a coefficient for this iteration. Okay. Similarly, we will this fractional value will work as a default value for the 0.104 for the next iteration. Okay. So, 0.104 is multiplied by 8, then we will get the value is 0.832. In this value we do not have the integer value is 0 basically in this. So, this 0 is the integer value and this 0 will act as a coefficient for this one. For the next iteration, this 0.832 will move here and it will again multiplied by the 8, and after multiplication 0.832 with the after multiplied 0.832 with 8, we will get the value 6.656. Okay. So, 6.56. So, 6 is the integer value and remaining this one 0.656 will be the fractional value. So, this 6 will move towards the coefficient column and this one go here for the next iteration. Okay. So, in the next iteration again we will follow the same step and we will multiply it by the 8 again. Okay. So, if we will multiply the 0.656 by 8, 8 6 ja 48, 4, 8 5 ja 40 plus 4 is 44, 4 is there, 8 6 ja 48 plus 5 2. Okay. Then again this is the value and the decimal point is after 3 digits. So, 3 digits. So, 5.248. So, in this the 5 is the integer value which will act as a coefficient for this iteration, while this fractional value is 0.248 will go to the next iteration. Okay. Then again we will multiply 0.248 into 8 and then we will get the value. If we have the 0.248 and we multiplied it by 8, then we will get the result 1.984. Okay, so in this 1 is the integer and this will act as a coefficient, and this 0.098 means this value will proceed further for the multiplication with 8, and then after multiplying this we will get the we will get the value 7.872, and in this is the fractional value and this is the coefficient. We will continue this process, this iteration, until unless we will not get the number of digits which is mentioned in the question after the decimal point, or either we will get the value 0. Okay, so in this questions we know the 0.406517, this is means we have to go up to 6 digit in this question. So therefore, as I have get the 6th iteration 1 2 3 4 5 6, as I get the 6 coefficients, we can stop this, and we to arrange this and these coefficients to get the octal number, we have to arrange these coefficient in a systematic manner to achieve the octal number. So we have to follow, to get the octal number we have to follow this arrow to arrange the coefficient. So all these coefficients will be arranged after the decimal point, because we are discussing the problem with the fractional system, fractional point number system. Okay, so here the value is, this is 0 point, means after the fraction, this is the fractional value. So we will get the octal number, but that will be the again fractional. Okay, so that's why we will put the 0 point and then whatever the digits, 4 is here, then 0 6 5 1 and 7. Okay, so we get the answer from this. Now next question. Till now I have discussed the two types of problem in which I have discussed about the integer numbers, the conversion of the integer number from one base to the another base, yani one number system to the another number system, and I have also discussed the problem in which fractional value is there and we are going to convert it from one fractional values to the another fractional value system of the another with the different base. So and I have also discussed the conversion of the binary to octal, decimal to the binary, decimal to the octal, decimal to the hexadecimal number, and reverse back as well. But now in this question is different, because in this system, in this question we have both this number, the decimal number consists of both the values, like we have the integer as well as fractional values. So how we'll handle this question, how we'll solve it, and we want the equivalent of 25.625 to the hexadecimal number. Okay, so so this will be different. So we have to divide this question into two parts. We have to solve separately for the integer value as well as for the fractional value. So we have to divide it for the 25. We can write down it like this, 25, and then separate each one 0.625. Okay, we will solve both the parts separately. Okay, so before to start, we should I want to discuss about the decimal and hexadecimal digits. So in the decimal number, like we have the numbers, in the decimal numbers we have the digits 0 1 2 3 up to this, and these are the decimal numbers, decimal numbers we have, and we know up to the 10, the hexadecimal number consists of 10 digits and 10 digits and 6 characters, and 6 characters are A, B, C, D, E and F. Okay, so we have to keep in mind all these things. Okay, So now to solve the integer values, we know that we will divide the integer value. Value will act as a quotient, and it will be divided by the base value of the number in which we want to convert the decimal number. Okay. So we want to convert this decimal number to the hexadecimal. For the hexadecimal number, the base is equals to 16. Okay. So that's why we will use 16 here. So 25 will be divided by 16. If we will divide the 25 by 16, if we will divide the 25 by 16, so 16 ones are 16, and then here 9 is there. Okay. So 1 is the quotient for the next iteration, while this 9 is available here. It means belongs to the hexadecimal number, means this digit can be directly used. Okay. So that's why we can use at a remainder. Okay. So remainder is 9 for this iteration, while the quotient is 1. Okay. Again we will go with the 16. We will divide the 1 by 16. So as the 16 is also the part of hexadecimal digits, belongs to the hexadecimal digits, and so that's why we will the quotient will be 0 for the next iteration, and this one act as a remainder. Okay. So remainder is now this 2, as per the previous, as I have already discussed about these things, this type of like for the integer number we have to follow this arrow. Okay. So now the number this will be the LSB, and this digit will be the MSB for the integer, for this integer number. Okay. Then we will get it 19, and base is 16. Okay. Okay. Now we have the second part of this question is the fractional value. So fractional values, we know how we will handle it, because we have to multiply this fractional value with the base value of the number in which we want to convert the decimal number. So this is the decimal number 0.625, and we want to convert it to the hexadecimal, and the base value of the hexadecimal number is 16. So that's why this fractional value will be multiplied by the 16, and if we will multiply it, we will get it 10 point. If we will multiply 0.6625 by 16 if we will multiply 0.625 into 16. Okay. So or this 16. Okay. So 6 5 is 30, 6 2 and plus 30 is 15, 6 6 is 36 and 37. Okay. Then 6 2 5, because the multiplier is 1 now. Okay. So 0 0 5 5 10, again 0 9 10 10 and 11. Okay. And so now we get the value is 11. This is 3 plus 9 is 6, 3 plus 6 is 9, and 1 is the carry here, so it will be 10. Okay. And the decimal point is after 3 digits, so it is 10.000. So 10 is the integer number here, and these 3 digits are the fractional. So fractional part is here of this number, and the integer part will be here, and this integer part will act as a coefficient for this one. Okay. So this value will move towards here for the next iteration, and if 0 is multiplied by the 16, then we will get the fraction part is 0 0 and then integer is 0 0. So that's why we have mentioned it 0 here. Okay. For the fractional values, we have to arrange the digits in this as per this arrow. Here Okay. So, now the value of this one, value of like 0.625 base 10 is equals to 0.0, okay, and this is 16, or we can write down it like 0.16. Okay. So, we get the value for the integer part of this question. We also get the fractional hexadecimal value of this fractional decimal number, and if we will merge it, then we will get the final answer. So, final answer of the hexadecimal number is 19.A, okay, for this question. Now, next question. So, till now we have discussed about the different conversion, like from from binary to decimal and hexadecimal to the binary, or different type of questions we have discussed. But now we have like multi-bit binary numbers, and we want to convert it to the hexadecimal as well as to the octal number. So, how we will tackle this one? So, before to start this numerical, I want to discuss about the octal number, because we want to in the octal numbers and hexadecimal number. So, in case of octal number, actually we have the maximum digit size is, the maximum permissible digit is 7, 0 to, we can go 0, 1, 2, 3, 4, 5, 6 and 7 for the octal. Okay. In case of octal, it means the highest permissible digit for this for the octal number is 7. So, for the 7, if we will write down the binary equivalent of the 7, so 7, then we have to do, we have to use the 2, because we want to convert the binary. So, this is 3 the remainder will be 1, then again 2, 1 2, 2 1 2, and then remainder will be 1, and then this one. So, the binary equivalent of the 7, if we have the octal number is octal 7 or 7 base 8 is equals to 1112. We know this is okay. It means what does it mean? We can conclude that any digits of the octal number can be represented by the 3-bit binary number. Okay. So, because the maximum bit size, maximum permissible bit for the octal number is 7, and 7 is nothing, just 111. Okay. So, it means the binary, we require the 3-bit binary code to represent any one of the bit for the octal number. Now, I will discuss about the hexadecimal number. So, in case of hexadecimal number, the bits are 0, 1, 2, 3, 4, 5 digits, 6, 7, 8, 9, okay, and then A, B, C, D, E and F. Okay. And F is equal to 15. Okay. F is equal to the 15. So, let's find out the binary equivalent of the 15. So, binary equivalent of the 15, 2, then 2 7 ja 14, and remainder will be 1, then 2, 2 3 ja 6, then remainder will be 1, then 2 1 ja 2, and question end will be 1 and remainder will be 1, and then we know we have to arrange the digits in this arrow. Okay. So, this is the finally solution will be like this. This is 2 is equals to nothing, just a F16. Okay. So, from this analysis we can say that any bit, because this is the highest permissible bit, h sorry f is the highest permissible bit for the hexadecimal number. So, from this analysis we can say that any one of the bit to represent the hexadecimal bit, we need the 4-bit code, 4-bit binary code, okay, because here the highest permissible bit f is just equivalent of 111, and this is a 4-bit binary code, okay. So, it means in case of hexadecimal number, if we want to convert the binary number to the hexadecimal number directly without any calculation, so we have to make the pair of 4 bit, okay, to directly we can write down the expression for that. Okay, now come to the question. So, the question is we have this binary number, okay, and we want to make the octal equivalent of this number, So, we will make the pair from the left hand side digits and right hand side digits from the decimal point, okay. So, from here, and in the case of octal, what is the size? The 7, and 7 is nothing, 111, it means 3 bit. We will make the pair of 3 bits, okay. So, we will start from here, this is 3 bits, these are 3, these are 3, and whatever remain in the last, we will make the simple one group, okay. Similarly, we will start from here, then and then, okay. So, from there here we can directly notice now this is the decimal equivalent of 3 1 1. If we want to convert it 0 1 1, this is nothing, 2 to the power 0, 2 to the power 1, and 2 to the power 2, as I have discussed in my previous lecture. I hope you have read it. You have here listened my previous lecture. So, from here if you want to convert it, like these are the coefficient and these are the place value. So, if 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. So, this is 0 plus this is 2 to 1 into 2 to the power 1, 2 to the power 1 is equals to 2, nothing else. So, 1 into 2 is equals to 2, then and this one 2 to the power 0 is equals to 1 into 1 into 1 is equals to 1. So, this is the 3. So, that is why we have write down the 3 for this, okay. So, it is very simple to memorize the 3-bit numbers, what will be the equivalent, and we can see it, and we can directly write down the value of these groups, okay. So, 3 and here 1 0 1 0 1, this is equals to 5. So, that is why we have write down the 5 here, okay. Now, next one is 0 0 1. So, 0 0 1, this is the most this is the LSB is just 1, it means what, this is 1 into 2 to the power 0 is equals to 1. So, this is 1, then this is 1, this is 1 1 0, it means 2 to the power 2, 1 into and 1 into 2 to the power 1 plus 0 is equals to nothing, this 6, okay. So, 6 is here, and then this is 1 0, it means this is 2, okay. Now, we will make the combination, what is the value of these 3. So, all 3 bits are high, it means the value of this one is equals to 7, and this is 4 1 0, and this is 0 0, it means all 3 bits are 0, the output will be 0. So, that is why we have make it 0, and now 1 1 0. So, 1 1 1 1 0 means this is 6, okay. So, 6 is here. So, we get the hexadecimal we get the octal equivalent of the given binary number, okay. Now come to the another question. As I have mentioned, in the hexadecimal number, the highest bit is permissible bit is f, and f is nothing, just 15, and this can be represented by 111. It means we have to make the pair of 4 bit. If you want to convert the binary number, so we can, if we will make the group of 4 bits each, then we can write down the equivalent to. So from here we will start from the decimal number 4 4 4 2. Okay, similarly towards this one. So these are the fast methods. So from this one we get it this, like this is 1011. 1011 means 2 to the power 3, 2 to the power 2, 2 to the power 2, 2 to the power 1, and 2 to the power 0. So this is 8 plus 2 plus 1 is equals to 11. Okay, and 11 is what? 11 is just, this is B, because A is equals to 10 and B is equals to 11 in hexadecimal number. So this is B. B is the equivalent of this one, and this one 4 bits, and the equivalent is 6 only. So we can write down the 6, and here we have the 12, and 12 is equivalent to the C is equals to the 12. So that's why we have write down the C, and last one is the 10. So 10 is just 2, and we can write down it as it is, because it belong in the hexadecimal number. We have the 10 digits which vary from 0 to 9, and second one is the 6 characters which start from A to and go to F. Okay, so 2 belongs to the 10 digits. Okay, so we can write down 2 directly, and this is the another group, all 4 bits, it means 15, and 15 is F is equals to 15. So that's why we have write down, and these 4 bits, all 4 bits are 0. Therefore the value of this, the hexadecimal equivalent of this binary code of 4 bit is 0, while the hexadecimal code of these 4 bits is just 6. Okay, so we can write down these these digits here and just put it base 16. It means this is the hexadecimal equivalent of the given number. Okay. So thank you very much, and if you have any query, you can write an email to me at rajeevnitj@gmail.com. Thank you.